Arithmetic instructions. Arithmetic instructions, right? In that, how many instructions are there in arithmetic instructions? 8. Add C, subtract, mul, div, increment, decrement, DA. DA is very important, we'll discuss. Add C is add with carry. Correct, right? Janavi. What is importance is in subtraction. For add, there is a hardware available. You remember ALU? A register, B register. In that ALU, only addition circuit is there. Adder circuit is there. There is no subtraction circuit. The way we have done it in using an adder circuit in 3 steps. What are the 3 steps? Take a 2's complement of a subtrahend, like add it. If there is a carry, complement the carry. Right? These are the 3 steps. Please mention that. There is no subtraction instruction. Subtraction instruction. Fan kadme ಮಾಡಿ. Reduce the fan speed. Subtraction instruction. There is no subtraction circuit in 8051. Hence SUBB instruction. SUBB instruction uses adder circuit to perform the subtraction. To do this, it will use following steps. First one, 2's complement of the subtrahend. Second one, add it to the minuend. Third one, complement the carry. If carry is 0, complement the carry. If carry is 0, result is positive. Number. If carry is 1, result is negative number, and if carry is 1, the result is negative number, and it will be in 2's complement form. Is this statement is clear? So those who has done this in the lab, subtraction of 8-bit numbers, which batch? A2 batch is done. A3 also done. Have you observed this carry and the result, whether it has been the 2's complement form or the original form? That you have to observe. If you are not observed, you have to observe. If you are not done, while doing it, please observe this. If your result is carry is 1, in such a case, your answer should be in 2's complement form. Please observe this in the lab. This is very, very important statement. This, we do not have any other lab experiments to illustrate this, but if you are doing project, somewhere it is useful. Somewhere it will come like result is minus, negative. Then you should convert the result into the 2's complement form again. How do you CPL? There is one instruction called CPL, complement the value. That will give you 1's complement. Then you have to increment that by 1, INC. So together, CPL and INC will give you a 2's complement of a number. Is it clear? So that statements are clear. These statements are clear, right? Done. Next one. Go to the multiply. We have mentioned all these instructions, right? The top we have mentioned all the instructions. Multiply instruction. It works only on A and B register. It works only on A and B register. That is MUL, capital MUL, AB, there is no comma. MUL, AB, there is no comma. For all other thing, add A comma B. There is no comma here. MUL, AB, right? Bit. If the result is 16 bit. A holds lower 8 bits or lower byte. A holds lower byte and B holds the higher byte. And B holds the higher byte. Right? Similar. Next one. Division instruction. Division instruction. DI. It also works only on A and B register. It also works only on A and B register. It also works only on A and B register. That is DIV. AB. That is A divided by B. B is the denominator, A is the numerator. This indication is applied, right? Why this is important? To understand what is denominator. Because if denominator is 0, then there is a problem. Right? This statement is clear? Till there, here. Comment a line and put A by B. A is the numerator and B is the denominator. The result is stored in. The result is stored in. A will hold the quotient. B will hold the remainder. The result will be held in A quotient, B remainder. You understood this? You understood this? It is B by A. Whatever comes, for example, if there is 3 and the answer is 2, this is a remainder, quotient holds the remainder. A holds the quotient, B holds the remainder. Right? On the division process. Now, please mention one more point. Please mention one more point. If B is 0, that is denominator is 0. If denominator is 0, then OV flag, OV equal to 1, OV equal to 1, CY equal to 0. CY equal to 0. OV will become 1. Why and how we'll discuss. Right now, you know that if B is 0 and you do the division operation, you try to do the division operation, then OV will become 1. CY will be 0 itself. Right. Is that written? Right. Else like OV equal to CY equal to 0. Else OV equal to CY equal to 0. Overflow flag and carry flag both will be 0. That means whenever you do the division operation and if OV flag is set, then there is some mistake in the operation. Clear? So, and you guys know what is increment and decrement, right? Will not write anything with respect. Oh, we have one point to be written. Next, increment, decrement instructions. Increment, decrement instructions. Increment, decrement instructions. This is very important point. Carry flag is not set. Carry flag is not set. Carry flag is not set. / decrement instruction rolls over. Rolls over. A carry flag is not set. A carry flag is not set when increment or decrement instruction rolls over. What do you mean by rolls over? Huh? No, rolls over. See, for example, you are incrementing R0. R0 holds FE. You have incremented it twice. If you increment it once, what will become? FF. What happens? It goes back to 0, 0. In this case, carry will not get set, but overflow flag will set. What we have written, if carry flag is not set when increment or decrement instruction rolls over, but overflow flag will set. Overflow flag will set. Rolls over is like when you are going to the maximum number and coming back to the minimum number. How it comes back, it will come back to the minimum number. Otherwise, you can also do this 0, 1, put the 0, 1 value, decrement it 0, 0. Once again decrement it will become FF. Roll over is like reaching a maximum number and going back to the minimum, or like reaching the lowest and going back to the maximum. Is it clear? Rolls over meaning. Okay? This is very important point. With respect to increment and decrement, the rest of the thing is same. Increment is add 1. Decrement is subtract by 1. What is that we have missed? DA instruction. This is very important. Write that instruction. Decimal adjust accumulator. Decimal adjust accumulator. DA instruction. It works with only A register. It works only with A register. This is very important. We should do one thing. Write it and then we will explain. That is DAA. That is DAA. It works with only A accumulator. This thing. The abbreviation for accumulator. Right? Why it is required? Why it is required? It is very similar to your DEC topic. You have studied half adder, full adder, then you went for the parallel adder, carry lookup adder, and all of those are working in hexadecimal operation. But finally you want the result in decimal operation. That is why you have designed hexadecimal to BCD or BCD adder. 2 BCD adders, you remember? If the result is more than 6, you will more than 9. Same thing will happen here. What this decimal adjust accumulator will do is, please write this. We'll write and then try to understand it. It adds 6. It adds 6 to lower nibble or higher nibble. It adds 6 to the lower nibble or higher nibble depending on the condition. Depending on the condition. Oh, before this we had mentioned one more point. DA works only. You cannot use it whenever you. It has to be used after addition instruction only. Right? Yeah. After that, like it adds 6 to the lower nibble or higher nibble depending on the condition 1. Condition 1. That is accumulator content 0 to 3 is greater than 9. 0 bits to 3 bits is greater than 9, or auxiliary carry is 1. Auxiliary carry is 1. In such a case, it will do A equal to A. The another condition is if accumulator carry, this is from 4 to 7 is greater than 9, or CY is 1. CY is 1. Then it does A equal to A plus 60H. A plus 60H. You can say this as 06 if you want to be very clear. It will be 6 means 06 only. 6 means 06 only. Auxiliary carry. When does? Occurs is like when it's third bit to the fourth bit if there is a carry. Right. This is a condition. What this condition means, we'll take an example. Example as what is that? We'll not write a program. We'll directly take an example. A equal to value, B equal to value, then add it and take the value. A equal to 47. B equal to some 25. Add it. I want the result in hexadecimal. Hexadecimal addition. Quickly. quickly. Shall we do it here? 7 plus 5 is 12 is what? C. Right? 4 plus 2, 6. The answer is 6C. If you do it in the calculator also, it has to be same. Answer is 6C. Now according to the condition, guys listen. According to the condition, the answer is again in A, right? That we are doing. The C is greater than 9. Then I have to add 6 to this number. So if I use the DAA instruction now, it will add 6 to this. Now what will be the answer? C plus 6. 12 plus 6 is what? 18 minus 15. 3. 3 is 1 3? Yes, 1 3. 1 3, 1 3. 6 plus 1, 7. So 73 should be the answer for this. Correct? Oh, I have done. How it is 72? Correct. No. 1 0 1 1 1 2. You understood how this is? If not, do the calculator. C is 12. 12 plus 6, 18. Right? Till 15 it is F. Then it is 1 0 1 1 1 2. You got it? You guys got it? 12. 6 plus 1, 72. So now it has to be 72. Now it has to be 72. Did you got it? What we have done in this is very simple program that you can write and understand it quickly. Move A comma hash 47H. Move R0 is add A comma B is there. Add A comma B instruction is there. Quickly tell me that. Add A comma B is there or not? Instruction sheet. Sir, elli instruction sheet elli. Jyoti, instruction sheet elli. Helbekin nanu. Add A comma B is there or not? Divya? There? No, right? So we'll take it in R0 if it is not there. R0 holds 25H. Then we say add A comma R0. Then we will say DAA. If you don't use this, guys listen now. If you don't use this instruction, your answer is 6C. If you use this instruction, the answer is 72. This is what you want. All these guys who are doing the counter, timer, display, everybody requires this instruction. Right? Is it clear? Result has to be in decimal. We are not, neither your calculator nor your watch, anything like you take, like nothing will work in hexadecimal. It's all decimal. So it has to be in decimal. Okay, done, clear. Now we'll change this number. We'll change this to 74 and 52. 74 and 52 will do. This is 6, this is C. Yes? 47 and 25 are in hexadecimal. Huh? 72 is in decimal. Oh, right. I got your point. What is this number? Right. 47 and 25 is just a number that you have to, you are, 25. This hexadecimal and decimal is for our representation. What works inside is only hexadecimal. Even if you write 47, just 47, it will take inside as hexadecimal number equivalent to that. You are understanding? What is hexadecimal and decimal is only for our understanding. What machines understand is only hexadecimal. You binary or decimal or hexadecimal, internally it does only hexadecimal operation. Hash 47 is No, 47 itself will store. That's what, like, machine will understand hexadecimal. I am giving hexadecimal. The 47 will go exactly as 47. If you give it as just 47, right, it will convert that to the hexadecimal. 47 in hexadecimal, that number will go inside. You are understanding? Itself. 47H itself, because what you are writing and what machine understanding are same. If you just write 47, for you it is a decimal. For internally when it goes, it becomes hexadecimal and goes. 47 equal to hexadecimal number is what? It will convert that to hexadecimal and take it. Then your 47 becomes something else. That is what, if you don't use anything, it is 40 decimal only. For you, for what internally goes is some other number. Can you quickly tell me what is 47 in hexadecimal? 2F. Internally it will become 2F. And 25? 25. 1? 19, correct. Now it will add this. If I give just 47 and 25, it will add this and give the result. Decimal, this thing. This is very important point. Yeah, he has raised it. It is very good. The point is that you should understand what machine understands. Alright, if you just give 47D or 47 or 47D, it is a decimal number for you. What machine will take inside is 2F and adds that to 19 of this. Then it will calculate the value. Then it will DAA, you do it. Then it will go to the, adjust that answer to the decimal. Is it clear? If you want 47 plus 25 or 74 plus 52, you have to give hexadecimal because this exact number goes inside. 47 means 47 goes inside. 25 means 25 goes inside. Is it clear? Machine works only in hexadecimal. It will not work in any other number format. Whatever the number it will give, it will understand only in hexadecimal format. It will calculate only in hexadecimal format. Addition also does in hexadecimal only. The result you have to convert that, and this is very important point. Like most of the people will confuse here. Please mention one point here itself. The machine will understand. Machine means your 8051. Hexadecimal only. Add the result you will get, like add this is a hexadecimal only. 42 you will get. Then you adjust that to the accumulate the decimal. It will be the 42 itself because of both this condition. This condition keeps it as it is, less than 9. 2 is less than 9. Not do anything. 42 it will keep it as it is. Guys, Harshit, you know. Please mention one point there. The machine works, machine in the sense in bracket 8051. The machine works only in hexadecimal number format. Hexadecimal number format. Put our star to that and keep it. That's all the statement. The machine will work only in hexadecimal number format. Is it clear? Right? Now, go back and change this thing, and like what it does is, in this case, it will add 6 0. Another discuss model. We'll come back to your point. Once, guys, listen. In this case, it will add 60 to the answer. So what will be the value? This will be 6. 3 plus 6. 12, 18. Again, this is the number. Where is the number? 12 is what? Like 2, 1. 126. It has to be 126. 6, 7 plus 126. Is it clear? Is it clear? Guys, is it clear? Nikhil, any doubt? Should ask. So that anybody else having the same doubt, for them also it will be clear. Hello. ಒಳ್ಳೆ ಹುಡುಗರಪ್ಪ ಹೇಳಪ್ಪ ನಿಂದು ಕ್ವಶನ್ Correct. Okay, okay. The question he is asking is, the opcodes are also in hexadecimal. The number is also in hexadecimal. Does your computer get confused between opcodes and the data? For example, 74 is a value now. 74 can also be an opcode. This is a question. This is a question that you are asking. 74 can also be an opcode. Correct? How does your computer or 8051 separate between 74 opcode and 74 data? ಹೇಳಪ್ಪ ಹೇಳು ನೀನು ಹೇಳು. Any other answer quickly? Sina, what is the answer? She is panic. Mind came suddenly when I say Anjana, suddenly mind came and sat into her brain. It was roaming around. The point is, your controller has no mechanism to separate separation between 74 data and 74 instruction. It is only in the sequence of flow that it understands. If 74, first whatever comes to it, it is the instruction. Once that is an instruction, the sequence will follow. If that is the instruction, next if it is move a comma hash, this is there. For this 74 is in 74 or 78, some opcode is there. This says that whatever data comes next, put that to A. 47 comes next, that has to go to A. So first is 74, second is 47, next is this might be 85, this might be 25. Now when it is done with 47, putting that 47 value in A, what? Though you by mistake you have written 25 here, or assembler done some mistake, and 25 is written, it will consider 25 itself as an instruction. It will not, there is no separate mechanism to separate between the instruction and the data. It is only in the sequence. Correct. Correct. Second stage is? I was absent for that class. Let's go. Next, go ahead. Go ahead. No. Those states are like fetch, decode, and like do the operation. Do the operation is what is happening. It will bring the 47 and put it in A. When it decodes, that it understands that like next value, whatever comes, it has to be put into the A. Then when it is saying execution, it does this. That is included in the one instruction. This 74 has a 6 states. This is all together. But minimum states are only 3. Fetch, decode, execute. Not necessarily. Not necessarily. Increment A. What data it has? Whatever the content of this is there, you have to increment. So first it has to fetch state 1. Second it has to decode that state 2. Decode means understand. Third it has to increment the value of A. A is 52. Now it will make that 53 plus 1. Then it stores back the accumulator. Right? So this is one process. It has 6 states. 6 states, 12. 6 states is one machine cycle, 12 clock cycles. But like in general, his question was in total general. Your question or your thinking is very particular. I believe he has understood. It is only and only in the sequence. If your sequence by mistake you have written wrong, then your program execution is wrong. However, logically your program is, if your that 25 and 80 application is interchanged, gone. Is it clear? Shall we go to the next point? Is it clear with this? Right? Is it clear with this? Oh, one more important point is there. Below, mention that. Bharat. What is yes jump instruction? Correct. Correct. When you fetch the S jump, it tells that Whatever the data comes next, put that to PC. Comes here is an address. That address will go to PC. Then PC will go to that location and fetch the instruction. You're understanding? Right. One more point we have to mention, below mention that. Auxiliary carry, AC. AC, we have not taken any example with AC, right? C. Guys, listen. Only previous example is C bantala. It has to be C and 3, right? C3 was there, C6 was there. Okay. If it is the condition, what is the answer? C6. C6 is 1, 8. 1, 8, right? 1, 2, 1, 2. 1, 2, sorry. 12 plus, correct. 1, 2. This is an auxiliary carry. This is an auxiliary carry. Though the result is less than 9, this is an auxiliary carry. Guys, listen, this is very important. Now 7 plus 5, 12 plus 1, 13. 13 is D answer. Now what I have to do? If it is DAA, what it has to do? Add 6. Okay, add 6, what happens? It becomes D8. Huh? 60H. 60H. 60, okay. 60 if I add, what happens now? D plus 6 is what? No, can you tell me D plus 6 is what? C plus 6 is 12, D plus 6 is 13. Correct? 138 is an answer. 7C, 56, 138. 7C is what in decimal? Let us finish this and go. 120? 124? No, yes. Yeah, sorry. Correct. The point in here is, when the answer is 7C, what you have to do is you have to convert that itself to the decimal. Then you have to add. How do you do that? You should put 0 there and add A comma 0, 0 and then DAA. This instruction is must for this. Okay? And
then last, you can convert it to decimal. So here, 12 plus 19 is 48 in hexadecimal. Okay, if you convert that to decimal, 16 plus 16 plus 16 plus 16 plus 8, you get 20. Exactly. 47 plus 25. 2f plus 19.
2f plus 19 is?
47 plus 25. That will be 42. If you add it like this.
Okay, if we add it like that, it will be 42.
48.
48.
It will be 48. So if you convert that to decimal, like 16 plus 16, it will be 30.
Okay. So what you are saying is, take the decimal value first and then like add it. Whatever the result comes, again that will be in...
Like if it's 42 and 2f you make. It's 47 and 2f. Exactly. If you make, add it.
Okay.
Then the final answer converted to decimal.
Okay. So...
Not adding 6. It's convert completely to decimal.
How do you convert like... that is like... Right. Only. Correct, right? 7C is 124. 124 idalla. Okay. Guys, let's do one thing. At the end, you have mentioned the auxiliary carry part. After DAA instruction details, at the end you mention one more statement. Auxiliary carry is used only for DAA instruction. Is used only for DAA instruction. No other instructions uses auxiliary carry. That is the meaning of this. No other jump on carry, jump on this, jump on 0. Nothing will use the auxiliary carry. Only DAA instruction uses the auxiliary carry. Only one instruction. Okay? Right. And last, we'll give some homework, right? Please write on the homework. Find the cube of a number anywhere that is there in the lab. Please do that. Find the cube of a number, cube of a number. After that, one homework you have to write. Sachin's score for last 10 matches. Sachin's score for last 10 matches is stored from the memory location 40H. This is a program that you have to write. Nikhil. Sachin's score for last 10 matches is stored from the location 40H. Find his average in BCD. Find his average in BCD. Find his average in BCD. First, you understood the question? Did you guys understood the question? What is this? It is the same program but this has to be in BCD, and you should use the division instruction. DIV. B value is 10. Is it clear? This question is clear. Any doubt in the question? I want you to do this in the lab also. Right? If after your arithmetic instructions, you have written multiply, add, subtract, do this also. Okay? Please include this in the lab. Please include this in the lab. Okay? Right. So, what we have left out with? There is no Adhubarabana. Right, please write the point. There is no floating point. There is no floating point arithmetic operations. Directly available. Directly available. But you can use math and then like calculate, convert that. For that, now listen, like arithmetic instructions available. There is no floating point arithmetic instructions available. And by default, by default, all the arithmetic operations are unsigned arithmetic operations. And by default, all the arithmetic operations are unsigned arithmetic operations. So, we have one more important point here. That is, we'll take this example itself. Okay. That is the concept of packed and unpacked BCD. Achha. Listen. 13 is a hexadecimal number, yes? Average? What is the best part of which is convenient to the question? You cannot calculate average. So you consider in every match he is out. Right to that, like please mention that also. Condition or consideration is that in all the 10 matches he was caught and bowled. Right. Listen. Yeah. Listen to me. The hexadecimal number 13, if it gets converted to the decimal, what happens? What is the number value? 16 plus 3 is 19. Right? This is called the packed number. When I unpack it, it is 0, 1 and 0, 9. No, what is this? 1, 0 and 0, 9. This is unpacked BCD. Unpacked BCD. Unpacked BCD number is used to convert this to ASCII number. Convert this to ASCII number. What is the 10 in ASCII? What is the 10 in ASCII? I think it is plus 30. ASCII number. 70. Huh? No. The ASCII is, this ASCII is stable. For every A, there is a ASCII character, ASCII value. 72, or what is the number for small letter? 67. Similarly, there is a ASCII value for 9. Correct. Correct, that is also right. Because there is, when the decimal, when we say, there is no 10 in decimal. There is 1 and then there is 0. So what is the change? It has to be 0, 1 only. 0, 1, that means it has to be 31. Correct. There is no 10 in the decimal itself. There is only 0 to 9. 10 is a combination of first two elements. 1, 0. 20 is a combination of second and first element. Right? So this is unpacked BCD. This is ASCII value. This is packed BCD. Now this is important for the program that we'll write next. Packed decimal number. Then we have to do unpacking and then convert it to the ASCII. Right? This is what happens in your keyboard. When you press the number 19, this is what happens inside. Your decimal 19, when you press, it will go 1 and 9. When you press 1, it takes as 31. When you press 9, it will take as 39. Internally, it will go and becomes as 1 again, 19 again. That is the arrangement this program has been written. Or your keyboard values will be arranged like that inside. Okay? So this concept is important for that. So we'll try to write this program in the next class. Right? Any other doubts? Any other doubt? So thus we'll, if you write this program and that Sachin program, then we'll finish this arithmetic operations. Then we have to deal with logical operations. Right? Totally how many instructions are done with data transfer and this? I are told 44 mnemonics are there totally. Did I told you that like 255 instructions are opcode? How many opcodes are there? 255. How many instructions? That is one statement mistake. Guys, listen. An opcode or an instruction has the same meaning. An opcode or an instruction has the same meaning. So there are 255 instructions or opcodes. 44 mnemonics are there. Please change that. If I mention one statement at the end. 255 instructions or opcodes. 44 mnemonics. What is mnemonic? Move is one mnemonic. Move X is another. Move C is another. Right? 44 mnemonics, 255 instructions or opcodes. It is same. Okay? How many of you written these instructions in the record? 2 batches have written, right? 1 batch done. The remaining guys are not written, right? So what is the plan? We will write a mnemonics, not all the opcodes. Right? We will not. No, I will only for the reason that, like we